All right, so in a previous video, we defined enthalpy of formation and what that corresponds to. Now let's go ahead and look at the applications of enthalpies of formation. So let's say we have this reaction, 2 moles of carbon monoxide reacting with a mole of oxygen to give us 2 moles of carbon dioxide. And our goal is to determine the enthalpy change for this reaction. Now what we could do is we could do a calorimetry problem, calorimetry experiment, and look at this reaction between these. Or what we could do is we could look at some known information that we have. Okay, this is the benefit of using enthalpies of formation. Since they are defined known values for how much energy change it takes to make carbon dioxide, to make oxygen, to make carbon monoxide from our sea level of elements in their elemental state, what we could do is we could use that to our benefit. And so we could say, well, this is the final, right? So this would be our final end enthalpy change. These would be our initial enthalpy changes. So what we're going to do is we're going to say, well, the enthalpy change for my overall reaction is equal to, okay, the sum of the enthalpy changes to form my products minus the sum of the enthalpy changes, so my enthalpies of formation, to form my reactants. Okay, so what we're doing is we're saying the overall change in enthalpy is equal to what it would have taken to make my compound from its element in its naturally occurring state, and we're subtracting from that how the enthalpy change corresponding to making our reactants. So we're taking our final minus our initial. So let's go ahead and look at what this looks like. So our overall enthalpy change for our reaction is equal to the enthalpy of formation of our products. In this case, it's carbon dioxide. We need to take into consideration how much there is, right? So we have 2 moles of carbon dioxide. The enthalpy of formation of carbon dioxide is negative 393.5 kilojoules for every mole of carbon dioxide. Okay, so that's my products. My products is my carbon dioxide. From that, we're going to subtract the sum of my reactants. So that's our carbon monoxide, so 2 moles carbon monoxide, and then the enthalpy of formation of that is negative 110.5 kilojoules per mole. And then we're going to add to that our oxygen. Okay, so we have 1 mole of oxygen. Now if we go back and remember when we talked about enthalpies of formation, this is an element in its naturally occurring pure state. Its enthalpy of formation is 0, right? It's our sea level. Okay, so now we have established a way to identify our enthalpy for our reaction, looking at our product enthalpies of formation, subtracting from that our reactants, right? Our final enthalpy of formation minus our original, our initial enthalpies of formation for our reactants versus our products. Then we can go ahead and calculate this, and we would get an overall enthalpy for our reaction of negative 566.0 kilojoules. Okay, so now we are able to identify the enthalpy for our reaction by looking at values that were presented for, that have been determined for us already, of our enthalpies of formation, looking at our final products minus our initial reactants, enthalpies of formation. So now we see we can use this as a great tool to understand and explain and identify the enthalpy for an overall reaction by looking at tabulated known values for enthalpies of formations for specific reactants and products. So I hope that you can get some chance to practice these and work on these, and if you have questions, we're going to work through those in class.